Welcome to 5-3 notes. We're going to be solving multi-step inequalities. Solve multi-step inequalities. To solve linear inequalities involving more than one operation, we're going to undo the operations in reverse of the order of operations. Remember PEMDAS, we just do it as you would solve an equation with more than one operation. So notice how for this equation, the very first example, we're going to solve it as if our inequality was an equal sign. So we're going to subtract 2x from each side. When we do that, these cancel. We simplify. So 6 minus 2x gives us a positive 4x. We're going to then add 4 to each side of the equation. So these cancel out. And we simplify 12 plus 4 to get 16. Now we have 4x less than or equal to 16. We're going to divide each side by 4 like we normally would and simplify. Once we get here, we are then going to write it in step builder notation. So our answer is x such that x is less than or equal to 4. And we're going to do the same thing on the other side. The only difference is when we get to our almost final step, when we have to divide by a negative number. So that's when we are going to flip our sign. Remember, when we divide or multiply by a negative number, we're going to change our sign. So let's do a few examples to make sure we remember how to do multi-step equations. So let's do number 7, because that looks like a tough one. We'll do number 12, and then we will also do number 3, as well as, depending on how we do number 6, we could flip the sign, and let's do number 5. All right, so let's start with number 3. So number 3, we have q divided by 7 plus 1 greater than negative 5. So first we're going to subtract 1 from both sides. Those cancel out. Then we have q divided by 7 greater than negative 6. We're going to then multiply both sides by 7. And our 7's cancel out here. 6 times 7 is 42, so it's a negative 42 greater than, so q greater than negative 42. So our answer is going to be squiggly bracket q such that q is greater than negative 42. So there's our answer for number 3. Now let's do number 5. So number 5, we're going to add 12 to both sides. They cancel on both sides. So we have negative d is greater than 4d. So now we're going to, let's add d to both sides. So this goes to 0 greater than 4d plus d is just 5d. So when we're here, I'm going to actually erase this line so I can write it on the next side. So we have 0 less than or greater than 5d. Now we divide both sides by 5. So we had 0 is greater than d. So just because we have 0 doesn't mean we stop. 0 means we still have a place to go. So our answer is going to be squiggly bracket d such that d is less than 0 squiggly bracket. That's going to be our answer. Let's do number 6. Number 6, I'm going to add 6 to both sides. That cancels. I have 5r greater than 8r. Positive or negative 18 plus 6 gives me a negative 12. Subtract 8r from both sides. Those cancel. We have 5r minus 8r gives us negative 3r greater than negative 12. So now we're going to divide by a negative 3. That makes a giant 1. Divide by a negative 3. So we're going to flip our sign. So we have our greater than, so we're going to make it a less than. So we have r on this side, r on the left-hand side. And then negative 12 divided by a negative 3 is a positive 4. So our answer is going to be r such that r is less than 4. Don't forget to change your sign. All right, let's do, oh, I skipped number 7. Let's do number 7. So you need to think about the top as its own entity. It's going to have parentheses. We want to first get rid of our denominator. So in order to do that, we're going to multiply by 2 on both sides. 2 on the left-hand sides cancel out. So we have negative 3x plus 6 is less than or equal to 12 times 2 is 24. Now we just have a two-step equation. Subtract 6 from both sides. Those cancel. We have negative 3x less than or equal to 24 minus 6 is 8. Let's see, 24 minus 6, 14, 18. So now we divide by a negative 3 on both sides. And we end up with x flip because we multiplied by a negative 6. So now we have our solution set, which is x such that x is greater than or equal to 6. Okay, so let's do one more. So 12, again, we're going to do the same thing. We're going to multiply by our denominator to get rid of it. What we do to one side, we do to the other side. Those cancel out. So now we have 4x minus 2 greater than or equal to negative 20. We're going to add 2 to both sides. So we get 4x greater than or equal to 18, negative 18. And so now we divide by 4 on both sides. It's a positive 4, so we keep the sign. And because all I want to do is really simplify this, we're going to simplify this as a fraction because it's not pretty. So we divide both by 2. We get 9 over 2, so 9 halves. So our answer is x such that x is greater than or equal to 9 halves. All right, let me check our answers. Yes, 9 halves. And I forgot that negative sign, so don't forget your negative. All right, so now let's practice writing out. Define a variable, write an inequality, and solve each problem. Check your solution. Don't worry about checking the solution. Okay, so we have a negative 3 times a number n plus 4 is no more than a number minus 8. So no more than, meaning it's the biggest it's going to get. So it's no more than that. So let's check, make sure we did that right. Less than or equal to. Do I have a less than or equal to? No, I switched the sign. I was able to get it when I taught first hour, but now I'm backwards. All right, no more than the number minus 8. So now we're going to simplify this. So we have, I'm going to write it to the side. So we have negative 3 n plus 4 less than or equal to n minus 8. And now we're going to simplify, subtract 4 from both sides. We have negative 3n less than or equal to n minus 12, 8, 9, 10, 11, 12. Subtract n from both sides. Those cancel. We have negative 4n less than or equal to negative 12. Divide both sides by a negative 4. Now we have n less, we have to switch sides. We multiply by a negative number. Don't forget. So we have n greater than or equal to positive 3. So our solution is n such that n is greater than or equal to positive 3. So go ahead, try the other ones, check your solutions. We're going to move on. So now let's see, what is the difference? So solving inequalities, when solving, we're going to use the distributive property here. So the only thing we're adding is the distributive property. So remember that whatever is in front of the parentheses is what we are going to distribute. So I'm actually going to work out the example over here because I feel like there's a couple things I want to talk about with this example. So what you need to do is always remember that the sign that's in front of the number goes with the number. So the sign that's in front. So here, this -2, I'm going to be distributing to both of these terms. So I'm going to have 3a. Now I have a -2 times a +6, so it's going to be a -12a. Now I have a -2 times a -4, because I want you to think of these as their own terms. So -2 times -4 is +8, less than 4. And now we have this minus that we're distributing because this is technically a -1 that's in front. So we're going to have -1 times a +4a, so that's a -4a. -1 times a +6, which is -6. So that's what's happening when we distribute. I really like how they had both of these examples in here for the distributive property. So now we're going to combine like terms. So we did the distributive property. We're going to combine like terms. So this is a term, this is a term, this is something different. I'm going to circle all my variable terms, and I'm going to box all my constant terms with the sign that's in front. So we have 3a minus 12a, which gives us a -9a. Then we have our +8 greater than. We're going to combine like terms. So that -4a is by itself, so I have -4a. Then I have 4 minus 6, which gives me a -2. Now it's just a simpler problem. Now we can actually solve for a. So we're going to add 2 to both sides because I rather add than subtract. So then we get -9a plus 10 less than or greater than -4a. We're going to add 9a to both sides. We're going to end up with 10 greater than -4 positive 9 gives us a positive 5a. So now we divide both sides by 5. And we get 2 is greater than a, which is exactly what they got. But this way, instead of subtracting, we're going to be adding everything. So now our answer should be a, such that a is less than 2. All right, so go ahead and try number 6, number 8, and let's do number 18. Because we've already done some problems like this, the only thing we're adding is our distributive property. So now let's talk about number 6. So number 6, we have that negative in front of our distributive of our parentheses. So we're going to distribute that negative. So when we do that, we're going to take -1, distribute it to each term. So we have -5x minus 2x minus 3 greater than or equal to 1. Now we simplify, so we have a -5x and a -2x to get us -7x minus 3 greater than or equal to 1. Add 3 to both sides. We're going to end up with -7x greater than or equal to 4. We're going to divide both sides by a -7. When we divide by a -7, we're going to have x flip the sign, and then we're going to have a -4/7. So that's going to be our answer. Don't forget to write it in set builder notation. So we have x such that x is less than or equal to 4/7. Let's check our answer, and that's what we get. All right, let's look at number 8. Again, you're going to include the sign that's in front of it because technically we are actually adding a negative, right? We're adding the opposite, so that negative is with the 2. So we're going to distribute that. So we have 8 minus 2b minus 2 less than 12 minus 3b. We're going to simplify as far as we can go, combining like terms. So 8 minus 2 gives us 6 less than 2b, or 6 minus 2b less than 12 minus 3b. When we do that, we're going to add 3b to both sides because adding 3b is going to give us a positive number. So I have a positive b, so 6 plus b less than 12. subtract 6 from both sides. We get b is less than 6. So our answer is b such that b is less than 6. Last but not least, let us do number 18. So we have twice the difference. So remember when we saw the difference, we have to put parentheses because same thing with the sum. We're going to be using parentheses of a number. So let's use n, and 4 is less than the sum, parentheses, of 5 and, or sum of a number and 5. So it means that we're going to have our n number plus 5. So let's check that before we do a bunch of work. Oh, difference, not sum. So we should have subtracted. I kept talking about a sum and it just went with my hand. All right, so now we simplify. So when we simplify, we're going to distribute the 2 to each term. So we have 2n minus 8 less than n plus 5. Add 8 to both sides because I want a positive number, and then I'm going to subtract n from both sides. Those cancel. So I now have n less than 5 plus 8 is 13. So that's how we get n such that n is less than 13. And we're done.